Hello, this video is being recorded to replace a video that posted that was entirely muted for the confidence interval difference between two means. So the notes start down here. Some things to note about the sampling distribution of mean in context A minus mean sub context B. Note your context must be defined. The order of the difference must be specified. And the subscript can indicate context. That can be confusing. If you use a word, it's usually less confusing. So now, let's come over here. So some new stuff. Similar to proportions, the very first check is going to be, do you have independent samples or do you have independent groups? Now, by the way, all of the checks now are always scored, so I don't know what you're going to do there. So always check this. Some things then, I make a table, context A, context B, and these three checks go in the table. Now here, I'm just going to use T as appropriate, not normal approximation. Randomness, as always, says random. For independence, population size in context A, is it greater than or equal to 10 times the sample size in context A? Keep in mind, you usually won't know population sizes. Over here, the same for context B. And then the T distribution is appropriate. This is where we're going to need to move to rarely the population is normal. And this is going to be true for both of them. Remember, you're checking them separately, one from context A, context B. So then if n is less than 30, I will typically make a box plot, but this could be done through a histogram, dot plot, etc. And look for outliers you don't want, or strong skew you don't want. And then if n is greater than or equal to 30, you have the central limit theorem. And just to save time, both of these apply also over here, but you would need to do the separate check in context B. So now the confidence interval. We are going to use the confidence interval to estimate, that's the key word with confidence intervals, the mean in context A minus the mean in context B. The checks are above. Calculate the interval. So, sample mean in context A minus sample mean in context B plus or minus the critical T, we'll talk about that, times the square root of standard deviation in context A squared over n context A plus standard deviation of B squared over n context B. And then there's a note about degrees of freedom below. But usually when I do my plugin step, I'll take note of which degrees of freedom. I will typically use my calculator. Just remember, do not pool. Pooling assumes this is true, and technically if you should be doing a completely different test if you were going to use that. So do not pool. The other option you have is choosing the smaller of NA minus 1 or MB minus 1. So that would be in context. If you happen to forget what's underneath the square root, the standard error, the difference of two means, here's your formula sheet. You probably have it framed on your bedroom wall right now. Take it down, take it out of the frame. Formulas on the first page are mostly first semester. On the back page, you're going to see one proportion and then difference of two proportions, and you see some of the stuff we did with proportions there. But down here, one mean, difference of two means. So if you don't know sigma, here's that formula. The formula is right there, so you don't have to memorize this. They use subscripts of 1 and 2. Make sure your subscripts indicate context more clearly. Then once you calculate, use 2 samp t interval to check. keep in mind, this is a frequent plugin step, and that's why I'm showing it. So 2-stamp T interval, this talks about degrees of freedom. Then once you're there, to interpret your interval, I am whatever percent confident, I am whatever percent confident that the true mean difference of whatever the context is between, and you can say it. Some possible follow-up questions: interpret the confidence level, interpret the margin of error, interpret the standard error, use the interval to comment on a claim. The big claim you usually comment on with an interval is if 0 is in the interval, then it is reasonable that there is no difference, because 0 is indicating that, keeping in mind this is estimating mean sub A minus mean sub B. If 0 is in the interval, it's a plausible value. And so if that difference equaled 0, then it's plausible that the mean of context A is equal to the mean of context B. So that's why that would indicate that. Okay, thank you so much.